Sometimes you need a task to happen at regular intervals outside of the main Volt application that you're building. Common use cases for this include sending weekly emails, polling an API for updates, and maybe generating reports. Although it's best to avoid background jobs when possible, occasionally it's unavoidable. The example I built today is a Bitcoin price monitor that observes a price average API in real time. Since this requires constant polling and cross-origin requests, you really don't want to handle it on the front end. One solution is to use a scheduler that regularly pings the API on behalf of all the users and then stores the results in the database. By the end of this video, you'll know how to make a runner script that executes code at regular time intervals, using something called the Clockwork Gem. Clockwork is a Ruby gem that builds recurring background jobs for any type of application. The tasks run outside of the main application as a separate process and use the special DSL that you see here. Most of the examples in the README relate to Rails applications, though. Let's take a look at how it's done using Volt. BitcoinAverage.com provides us an API to check current Bitcoin prices in JSON format. The example today is going to periodically download this JSON price information and cache it into the Volt database in a collection called Prices. Since Volt will reactively publish updates to any user that observes a collection, that's really all we need to do to get real-time updates. Volt knows when to re-render the page, and we just need to fetch and store the JSON data on our end. If you decide to try this project out on your own, be sure to check out the Bitcoin Average API terms of use before you get started. The most important limitation is that you shouldn't pull the API more than once per minute. Also, make sure that you're running Volt 096 pre-1 before you get started. Previous versions of Volt won't support the features that we're going to use in this video. While I'm in the gem file, I'm going to go ahead and add the Clockwork gem also. Then we need to write a runner script that Clockwork will execute. I'm going to name this script fetchprices.rb and place it into the root of the project. Location of the script is not super important, so just pick a place that makes sense for your project. First, I'll require in all of the dependencies. After that, we need to boot the Volt app. This allows the current script to tie into the Volt message bus and keep other Volt instances aware of database changes. If you don't do this, you're going to have trouble fetching your updates in the browser. After we do that, I'll build a Singleton class to handle clock ticks. So in this basic example, I'm creating a handler that uses this block that you see here. The handler gets passed a job whenever this time frequency is called. So in this case, every 61 seconds, we're going to throw in our Singleton class into this block. The DSL is pretty simple, but let's see what this does before we add any API fetching logic. You run the Clockwork script by typing clockwork, followed by the name of the script. When you deploy the app, things will be a little different. So be sure to check the Clockwork documentation for details on how to set up your production server. I went ahead and sped up our handler to execute every 2 seconds, just for demonstration purposes. When you add your API fetching logic, you want to make sure you're doing it at no more frequent than 60 seconds, just to avoid any rate limiting on the API. So, as you see from the messages that we're seeing here, our event is firing every 2 seconds, just like I put in the Clockwork script, and that was our intention. So now we need to go back and we're going to need to add the API fetching logic that's going to put records in the database relating to Bitcoin prices. I'll add the API URL as a class level constant on the Singleton class, since this is never going to change. Then I will fetch the JSON off of the API using Ruby's NetHTTP library. This is just performing a simple HTTP GET request. Once we have that, we need to transform the text body into a Ruby hash using the JSON library. And like you saw at the beginning of the episode, the hash is going to look something like this. Since I only care about the Coinbase price in my use case, I'm going to save a variable that disregards all the other pieces of the JSON data. Then lastly, I'm going to push it into the prices collection in the database. This is the magical part that allows us to transparently push price updates to all connected web users on the front end. We're just adding a new record to the database every minute that reflects the most recent Bitcoin price data. Another way to do this would have been to update an existing record to save disk space, but that's something I'm not concerned about in this use case. Your use case may differ. If you don't understand this code on line 14, consider pausing this episode and watching episode 10, where I cover Volt models a little bit more in depth. Now we're done creating our Clockwork script. Let's paste in an HTML template to observe real-time price changes in the browser front end. Whoops, and it looks like I almost forgot to set it back to 61 seconds. As you remember in the last scene, I had it at every 2 seconds for demonstration purposes. Now that we're dealing with real API calls, we want to make sure we're not hitting the API too many times, so went ahead and changed that back. Okay, so I wrote some HTML ahead of time for the view. As you'll remember, we were pushing a new record into the database every minute using the Clockwork script. That means that the value of the content binding that I've highlighted here will change every minute also, since it's rendering the last record in the collection. That's really all there is to do. Every time a new record gets added, the value that the .last refers to is going to change, and it's going to update in real time on the front end. And now let's go back to the browser to make sure that everything worked correctly. I'm going to go ahead and fire up the Clockwork script right now. And there we go, the price changed. So very cool. There we go. We have a nice auto-updating real-time price monitor with very few lines of code on our part. That's all for today. Subscribe to my newsletter if you want to be updated about new episodes as they come out, and thanks again for watching. I'll see you next week.